Hi folks, welcome to 3.4 part 2. And in this section, I just wanted to do a couple extra examples so that we might have a better idea of how to find that end behavior, the zeros and their multiplicities, but also come up with a potential graph. Okay, so let's start with example 5 here. So we're given this polynomial y equals negative parentheses x plus 1 times x minus 3 squared times x plus 4 cubed. Now, I see here that I have 1, 2, 3 different zeros, right? And so if I have x plus 1 as a factor, that means when I set it equal to 0 and I solve for it, I get the 0 associated with that factor. All right, so this 0 is x equals -1. And the power up here, there's a secret 1 here. So we can say the multiplicity is 1. It shows up 1 time. What about the second 0? So x minus 3 equals 0. We solve, we get x equals 3 as another 0. But this time, the multiplicity is 2. And last but not least, I've got x plus 4 as a factor. And when I set that equal to 0 and solve, I get x equals -4 as a 0 with a multiplicity of 3. Now, 1, 2, and 3 are great pieces of information in the multiplicity column, but maybe when we start thinking about how to sketch a graph of this, we want to make sure that we know whether that multiplicity means that we cross the x-axis or we bounce back, all right? So remember, every odd multiplicity, 1 and 3, those are going to cross the x-axis, all right? But every even multiplicity, so even multiplicity, not like the 0 is even or odd, okay? So even multiplicity means that we bounce back, okay? Now, the last thing we need before we can sketch our graph, we need to think about our end behavior. And in order to do our end behavior, we need to find the degree and the leading coefficient of our polynomial. And so I see here my polynomial is in factored form. So in order to find the degree, I have to take all my exponents and I need to add them together. So degree is 1 plus 2 plus 3, which is 6. And then my leading coefficient is negative. All right, so degree is 6. Leading coefficient is negative, and all of that means my end behavior is down, down. Okay, so even degree, negative leading coefficient means the graph goes down on both ends. All right, so how do we sketch a picture of this? We're going to come down here. We're going to draw ourselves a nice little grid. And we're going to mark off our zeros. Those are really the only points that I care about. The zeros and then making sure our end behavior matches, all right? So I'm going to have a 0 at -1, at -4, and at 3, okay? So those are my 3 zeros. I know I have to start down and I have to finish down. So let's see what happens at each one. At -4, our graph will cross. So that might look something like this. Cross through. At -1, it also crosses through. So I'm going to come back down. And at 3, at x equals 3, our graph will bounce. So I have to sort of go down a little bit, come up to 3, and then bounce back. All right? So this, my friends, would be how we would fill out this chart, identifying the important information of zeros, multiplicities, and behaviors, and using all of that to come up with a graph. All right, let's take a look at one more. All right, example 6. looks like this time we have multiplicities, but we don't have any other information. That means we have a lot of freedom, all right? So answers may vary here. Answers can vary. They can be different, okay? I'm just going to go through one example of a possible polynomial. So let's say I want my first 0 to be -3. I want my second 0 to be 0. And I want my last 0 to be 1. Okay, now I could make up any number here, but I'm choosing -3, 0, and 1 because I felt like it. Now, what this means now that I have my zeros is I can write my polynomial. And it's probably easiest to write this in factored form, okay? So if x minus 3 is, or x equals -3 is a 0, then x plus 3 is the factor. And it has a multiplicity of 3, so I need x plus 3 cubed. The next 0 is x equals 0, and it has a multiplicity of 2, so x squared. And then last but not least, if x equals 1 is a 0, then we know x minus 1 is a factor, and that has a multiplicity of 2. All right, so here I have my polynomial. All right, now the way this is, let's see what the degree is. All right, degree is 3 plus 2 plus 2, which is 7. Okay. Now, right now, my leading coefficient is positive. That means my end behavior will be down, up. Right? But if I wanted to put a negative here, then I would just change this to be up, down. All right. All right, let's go ahead and draw a grid. Let's see how we can shape this particular graph. All right, so we'll go about it the same way again. Let's put in our zeros first. So -3, 0, and 1. And I know that I have down and up for my end behavior. And so maybe I go back to the multiplicity. I see that 3 is odd, so that is going to cross there. But these two zeros have even multiplicities, so they are going to bounce. All right, so I'm going to come to the -3. I'm going to go through, cross. I get to the 0, I'm going to bounce. I get to the 1, I'm going to bounce. And then I'm going to connect it to the other end behavior. Right, so here's one possible graph for this, but again, answers may vary. So if you got something different and you're not sure, feel free to send me a message and let's see if yours is correct or not. All right, have a good day, folks.